In this lesson, what we're going to do is we're going to look at our regression coefficients, our thetas, in more detail. So far, we've discussed how to interpret the value of our coefficients in both the original linear model and the log linear model after our data transformations. The thing is, if we're looking to predict house prices, we're not just going to be interested in the sign and the size of our coefficients, we're also going to be interested in their significance. Just because there's a number next to a particular feature does not mean that this feature has much explanatory power. Just because there's a number here doesn't mean that this feature is actually significant. Remember how we talked about how a doctor checks your vital stats? A regression coefficient's vital stat that tells you about its significance is called the p-value. Now, most academic research papers that you come across analyze the significance of their findings using this metric of p-values. And here's how this metric is typically used. If the p-value is less than a certain threshold, that threshold being 0.05, then the result is deemed statistically significant. And when the p-value is greater than 0.05, then this result is considered to be not statistically significant. This threshold of 0.05 is kind of where the consensus amongst academics is regarding significance. And for better or worse, there's a little bit of a cult around this particular value. When it comes to calculating the p-values, the scikit-learn's linear regression model isn't actually much help. So what we're going to do is we're going to look beyond the scikit-learn module to calculate our statistics for our regression. We're going to go beyond the simple linear regression provided by our machine learning module. In these lessons, we're going to be looking at some detailed statistics of our model. And this is why we're going to be importing a different Python module to take us further here. And this Python module is called stats model. Now let's add a section heading. So I'm going to change this cell to Markdown, and I'm going to put a section heading here that reads p-values and evaluating coefficients. What we're going to be doing next is we're going to be using the stats model module to run our linear regression. And we will run it so that we get the same results as we would with scikit-learn. However, we will be able to use this Python stats model module to pull up detailed statistics that we can't easily get with scikit-learn. The first thing that we need to do, of course, is import our stats model. So we're going to go to the top of our notebook, and in our first cell, we're going to say import statsmodels.api as sm. Then I'm going to hit Shift Enter on the cell. And what I see when I do this is there is a deprecation warning here. This deprecation warning refers to my stats models module. And what it's saying is that at the time of recording, this module is still using a component that is outdated. So it's using this pandas date tools component, which is outdated or deprecated. Now, I'm really not too concerned about this for two reasons. One is that we're not going to be using any functionality to do with dates from the stats models API. And two is that the stats models API will also be updated by the people who created it. And what they will do is they will make sure that it doesn't break and that it's maintained in good working order. So by the time you're running this, you may or may not see this deprecation warning. Now let's run our regression with this new module. The thing to note is that in order to make our regression tie out with scikit-learn, we're going to have to add an intercept. Because as you can see, there is an intercept here from my regression with scikit-learn. So what I'm going to do is take our features from the training dataset and add an intercept. So I'll write sm.add_constant parentheses x_train. And what I'll do is I'll store this modified data frame in a new variable. So what I'm going to say is x_include constant equals sm.add_constant parentheses x_train. Now what we can do is call on the stats models OLS function, which will give us back a model object, which we can then use to fit our regression. So I'm going to say model is equal to sm.ols parentheses y underscore train, comma, x underscore include underscore constant. What we're doing here is we're calling the OLS function. OLS stands for ordinary least squares. And just like scikit-learn, this gives us a linear regression model, which we're storing here. As arguments, we've provided our target values and our features. And these features include this constant that we've added. Now we can use the stats models API to fit our regression. Fitting our regression will give us some results. So I'll create a new variable called results and set that equal to model.fit. In other words, calling the fit method on the model will return to us our regression results. So the question is, how do we take a look at these results? For starters, let's see if we can print out the coefficients like we have here. To get these coefficients, we'll use the results params attribute. So results.params and shift enter will show us the coefficients. So here they are. And these values tie out with what we saw in scikit-learn. I'm going to comment this out. And now we can take a look at the p-values that I keep harping on about. To show these, we also use our results object, put a dot after it, and access the p-values attribute. So results.p-values and shift enter will show us the p-values for all our coefficients. Now, I don't think this is formatted particularly nicely, so what I'm going to do is I'm going to comment this out again and put both of these two series into a data frame. So with pd dot data frame parentheses curly braces single quotes coef colon results dot params comma single quotes p-value colon results dot p-values, we can look at our coefficients and their p-values formatted nicely side by side. Check it out. Ta-da! Now this is starting to look pretty good, but you know what? I found these p-values really hard to read in scientific notation. So what I'm going to do is I'm going to round them. I'm going to come up here where I'm creating our data frame, and I'm going to call the round function. So round, open parentheses, closing parentheses before the curly brace, and then comma, and then a number of decimals that we should round to. So I'm going to go with 3 and refresh our output. Now let's talk about how to interpret these results. Well, remember the rule of thumb that any p-value over 0.05 is not significant. In our case, 2 of our features fail this test, namely the indus feature and our age feature. These 2 features do not appear to add much additional information. All the others are indeed statistically significant. Now, let's make a note of this for later, because maybe we can remove the indus and the age features from our model. In the next lesson, we're going to discuss a potential problem in our regression. Remember how we had high correlations between our features? In the next lesson, we're going to check formally if our regression suffers from the problem of multicollinearity.